I'd like to start our lesson with 5.2, substitution method today. Now from 5.1, what you learn is graphing, not just one line, but two lines. We call that a system of equations. So I'm going to start with something very similar to that right now. Here's an example. X plus 3y equals to 12, and the other one is x minus y equals to 8. Now I want you to graph this. Remember, we have several methods to graph this. You can either solve for the slope-intercept format, use that to graph. Remember, this is the slope-intercept format. Or we can also use the x and the y-intercept, meaning you solve each equation for its x and y-intercepts and then use those 2 points to graph the line. So I don't care which one you do. I'm just going to do one of each so you see how it can be done to graph each line. So for instance, for the first one, I'm going to use the slope-intercept format. For the second one, I'm going to use the x and y intercept. So for the first equation, I'm going to solve for y. So when I solve for y, I would definitely minus the x over. So I would have 3y equals to negative x plus 12 divided by 3. Y equals to negative 1/3 x. Notice I want to put it back into the fraction form because I need to use my slope to move to the second point. And then 12 divided by 3 will give you 4. So I got my first line into a slope-intercept format. Now I'm going to go ahead and show you how to get the x and y-intercept again. Remember, for the x-intercept, we set y equal to 0. And then for the y-intercept, we set the x equal to 0. Okay, so with that in mind, when I substitute y into 0, my equation is going to look like this: x minus 0 equals to 8, or x simply is 8. So for that point, it's going to be 8, 0. First point is done. For y-intercept, I substitute x 0, which is 0 minus y equals to 8. 0 minus y is still negative y equals to 8. Since I have a negative y, I have to get rid of the negative by either multiplying both sides by negative 1 or divided by negative 1. You can decide on that one, which will become negative 8. So therefore, my point for this one is 0, negative 8. Okay, if we continue on, let's show you the graph. Let's graph this x minus y equal to 8 line. I'm going to graph them both on the same coordinate plane. So here we go. This is 8, 0, so that means I'm going to go over 8 units. 4, 5, 6, 7, 8. 8 zeros right there. And this one here I have to go down 8 units because it's the y-intercepts. 1, 2, 3, 4, 5, 6, 7, 8. I know it's not quite accurate here, but you kind of see what's going on. So I got my 2 points. Let me connect that, and there you have it. I got myself a line. First line. Now I can use the slope-intercept format here to graph my second line. So this tells me to go up 4. 1, 2, 3, 4. And my slope tells me to go down 1 and then right 3. So down 1, right 3. So it's going to be right there. If I connect these two, I will have a line looking like that. Okay. So you kind of see what's going on there. You see it. Let's go ahead and try to estimate what this is. From the look of it, it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9. So the intersection is at, I'm just going to go ahead and draw it right now. Approximately, I'm looking, and it's about 9, 1. This is what we call a solution of this system, right? This is a consistent system. It's independent because we only have one solution. Remember, you learned this in 5.1. Well, we have infinitely many solution, meaning you have one line on top of the other line. That's called consistent but infinitely many, right? It's a dependent system in that case. And we have the other one with no solution, meaning parallel lines. That's called inconsistent system. Now, what's the deal with substitution method for today? Well, it's actually is another way for us to get to the exact solution without having to graph. Okay, so I'm going to go ahead and use the same exact system equations right here, and I'm going to show you how to solve for this intersection algebraically. So let's copy this over. It's going to be x plus 3y equals to 12, and I'm going to have x minus y equals to 8. So let's start that off. Notice it is the same exact equation. I'm trying to prove it to you that using a substitution method, I can also get the exact same answer, or at least, this is what I approximated. We'll see if that's going to be accurate or not, because the substitution method is the way to go if you want to obtain an exact solution. So the key step to a substitution method is that here's the first step. You need to pick one simple equation. Okay, you got to pick one that looks the simplest to you, and then solve for the simplest variable in that equation. Okay, so if I were you, I would definitely pick that one because it looks simple, and I know that I also want to solve for x because it's the easiest to solve for. Okay, so I'm going to go ahead and pull that aside right now. That's what I picked. I pull that aside and I start solving for it. So if I want to solve for x, I would be adding the y over. So that means my equation now becomes 8 plus y. X equals to 8 plus y. Why is it so important for us to write it in one variable? Because remember, this is called substitution method. So that means the second step is once you're done solving for a variable, okay, once you're done solving for that single variable, what you want to do now is go ahead and substitute it into the equation that you did not use to solve for. So in this case, the equation I'm going to be using, I'm just going to go ahead and try to show it to you right here. This one right here, we didn't use it yet, right? So I'm going to go ahead and drag it down. X plus 3y equals to 12. What you do right now is to go ahead and substitute it. If you see your equation right here, we solve x and make it equal to 8 plus y based on our simplest equation. All that you need to do is just go ahead and substitute the content of x into the other equation. So whatever x is, I'm going to replace that x with this right here, 8 plus y. So you see it right here. X is 8 plus y, isn't it? X is 8 plus y. So therefore, if I see an x, I can replace that into x. Okay, be very careful with that, okay? And so my next step would be to go ahead and replace it. So whatever x is, I replace that with 8 plus y. Okay? If you have to put in extra in parentheses, so be it, to show you that I just did a substitution. Okay? So now, notice that we have an equation, a new equation with same term, same variable. So now we can just go ahead and combine it. I got y plus 3y, which becomes 4y. And now it's just a regular equation. I can solve for y by subtracting 8 both sides. I got 4y equals to 4 divided by 4. Y is 1. Now I got y component. I need to know what my x is, right? So since I know my y, I can always take this and substitute y back into any equation I want. But since I already have this solve for x, I might as well just reuse that and plug y back into here. So let me just go ahead and pull that and reuse it. Remember, reusing is the key here. So you got x equals to 8 plus y, and since I know y is 1, I can just substitute it. It becomes 8 plus 1, which is 9. So I know that my x is 9. If I put these two back together, it will be 9, 1. Now let's compare it to what we just did earlier. Look at this. Don't we have the same exact answers? And this is what we call the substitution method, solving it algebraically. Okay, so what I just showed you here is that when you're done solving for a single variable, you substitute it. The other equation, substitute into the other equation. Okay. Substitution is a key, as you can see. I'm going to show you another one here. Make sure that you understand it fairly well. Remember, this is called a consistent independent system because we're having exactly one solution. I'm going to show you another variation to this. So pretend for this example right here, I have 2x minus y equals to 8, and the other equation is y equal to 2x minus 3. Remember our first step. We want to choose our simplest equation to solve for if the variable is not already solved. In this case, we notice that since this equation has y already solved for, we don't need to do any extra work. All that you need to do is just go ahead and substitute whatever y is directly into the other equation. Okay, you see what I just circled? I circle to indicate that this equation has been solved for, or this is what I want to pick to solve. However, since it's already done for us, you can just go ahead and substitute whatever y is into the other equation. So I'm just going to go ahead and drag it aside and show you that whatever y is, I just can go ahead and substitute the content of y into the other equation. So don't forget, here's the tricky part though. Remember I told you to go ahead and put in extra parentheses when you do a substitution? This is a good place to do that. Or actually, you know, just remind yourself that whenever you do a substitution, put parentheses around what you just substituted. In this case, it's 2x minus 3. Why is it so important? Because this negative right here will be distributed into each term inside. If you don't remember that, your answer will be off. Okay, so check to make sure. So when I substitute and distribute this right here, I would have negative 2x plus 3 equals to 8. I solve for this completely, but this time I noticed that, hey, all my terms are gone. 3 equals to 8, that's not true. So you know, since 3 is not equal to 8, what we have right here is an inconsistent system. Meaning no solution, okay? So we would expect that if I graph these two lines, you expect to see two parallel lines because this is an inconsistent system, okay? So no solution in this case. And the last case right here will be something like this. 4x minus 3y equals to 1, and the other one is 6y minus 8x equals to negative 2, okay? You look at this one right here, you're trying to use the substitution method, right? So we want to pick, go ahead and, since neither equation has been solved for, I want to pick for the easiest one. I'm looking at it right now, and I realize that's fine. Let's pick the top one. It looks simple enough to solve for, so I'm going to go ahead and circle that one. And in this case, I want to go ahead and solve for x, right? Technically, it doesn't really matter what variable you want to pick to solve for. But in this case, I want to solve for x. So if I want to solve for x, I would move the negative 3y over by adding it to the other side. So I have 4x equals to 3y plus 1 divided by 4 both sides. So x would be 3/4 y plus 1/4. Okay, so it looks kind of complicated right now, but it's okay. So whatever x is in the other equation, I can substitute the content of x over here into it. Remember, when we do our substitutions, don't forget to put in extra parentheses, like this. Whatever x is, I know x equals to the content here, so I can just replace it with 3/4 y plus 1/4. Okay, this is called substitution. And I can just go ahead and simplify. Well, as it turned out, it's actually pretty easy because you can cross cancel right there. So this becomes 8, cross cancel with the 4 will give you a 2. Okay, 2 times 3 is 6. Don't forget the negative in front, which makes it negative 6y. Now, for those of you who don't like cross cancel methods, you can just multiply across. Negative 8 times 3 is negative 24. Negative 24 divided by 4 is also negative 6. Okay. And of course, negative 8 distribute to 1/4 will give you just negative 2. So I'm going to go and see this time the y cancel out again. So I have negative 2 equals to negative 2. Unlike our previous case, we have the left-hand side equal to the right-hand side because they are equal. You understand that that means we call this a dependent case. And it's consistent, of course. What it means is you have one line when you graph right on top of the other one. Okay, so that means every point on the line is being intersected. So therefore, you have infinitely many solutions. Okay, so there you have it. We have I put in 3 scenarios for you. one with only one solutions, one with no solution because both lines are parallel, and the third one is one on top of the other, or we call this a dependent system, consistent system. Therefore, we have infinitely many solutions. I want you to go ahead and work on these 5 problems before you get back to class the next day. This is on page 63 in your workbook. Okay, this is page 63 in your workbook. Work on number 2, 6, 9. I'm gonna kind of go out of order here. Let's do 3 and of course 12. Okay, trying to challenge you a bit here. So 5 problems. Make sure you complete this. If you need to stop the video or watch it again, please do so. I know it's a lot of examples in one video, but you need to see this again if you have to. Okay. All right. I'll see you.